Hello mentors, let's explore the dice bingo so you and your students take a paper or notebook and build your bingo board. It's important that students actually show you the board using the webcam. So they can use any numbers from 1 to 18 and they may repeat number. To win they need to check each number twice, so 8 checks total. And on each round what we're going to do is we're going to roll 3 dice, either virtual dice or real dice, and hopefully they're real, and we add the numbers. So here's some examples. Let's actually do a more thorough example. And so let's say I'm a student and then I get a piece of paper and I write these 4 numbers, 4, 8, 15, and 11. And let's play a few rounds. So a single mentor rolls these dice, 6, 3, 6. We compute the sum and that's 15. So the student can check one of the 15. Okay, so good start. Then you get 2, 5, 2 for a sum of 9, so nothing happens, and so on. 11, that's good, let's check that. 10, nothing happens. 7, nothing happens. 11 again, oh, that's great. 11 again, well, nothing happens because you already checked your 11s, and so on. That's how the game goes. So the natural questions after playing the game and decided who won is which are the best 4 numbers to pick for the bingo. And we see right away that 1 and 2 are not good options because it's just impossible to add to 2 or add to 1 when you roll 3 dice. But so the next question is, okay, are they all equally good? So it doesn't really matter. It's just a totally random bingo in which there's no strategy in picking numbers. And if not, how can we find the odds of each of these numbers from 3 to 18? And also, is it a good idea to repeat numbers in our board? Or is it better to just have different numbers? So these are the guiding questions for the exploration. And so first, it's important that students see that there's lots and lots of rolls and order matters. So for example, 255 and 525, they're not the same rolls. But how do we count them? So a simplifying process would be, okay, let's assume that the first die is a 1. So we already rolled a 1. So how many options are there? And a table is a very powerful way to see that there's actually 6 times 6, so 36 outcomes in which the first die roll was a 1. And then you can see, of course, that multiplying by 6, and by the same logic, you'll get 36 times 6, so 216 possible outcomes. So there's a lot of outcomes here, 216. Now, how can we represent these outcomes and, by the way, see what are their sums? Well, we use these tables, so these are just the sum tables. So for example, I can say here that if, like in this first, like if my first die is a 1, and then my second roll it's a 5, and my third roll is a 2, so I'm here, adding 1 plus 5 plus 2 gives me an 8, and so on. And so these tables are awesome. Look like, for example, in any table that the numbers grow like diagonally. So I have a 5, 2, 6, 3 7s, and these are not single rolls, but actually the sums. Oops, sorry. And so this is a way to see all the 216 possible sums, of course with repetitions. And then you can see that there's only one 3, because there's only one way to roll a 3 in the sum, 1, 1, 1. And symmetrically, there's only one 18. That's my 6, 6, 6. But for example, there's 2 ways to roll a 4. And that would be 1, 1, and 2, 1, 2, and 1, and 2, 1, 1. So it's having 2 1s and 1 2, and the 2 can be put in the beginning, in the middle, or in the end. And then it's very easy to count how many oftentimes would you get a specific sum. Let's evolve. So we know that we have already 216 possible outcomes, and so these lines would be those outcomes. How can we organize them? Okay, we already organized them here, more or less, and actually showing their sums. And so let's just do that, separating by the sums. So the purple numbers here are the actual sums, and so these are called frequencies. And so, for example, as we already noticed, getting a 3 as a sum, there's only one way. And so 1 would be the frequency of all these, rolls that get me a 3 in the sum. Similarly, for a 4, there's only 3 outcomes. And this is symmetrical, so that's really good, this shape. So here would be the mirror. And so what we see that close to 10 and 11, that's the sweet spot, that's the best. So there's a lot of ways, actually 27 ways, rolling these dice that you can get a 10, and the same for 11. Here it's for 17 again. There's only 3 ways to get 17, which is totally symmetrical to the one we already talked about, the 4. What do we do now? Well, we start taking conclusions, but before, if we actually want to represent these bars in a different way, using a pie chart, what we could do is count the frequencies. So those would be the frequencies of each roll. And so here we would get that 11 and 10 have, a lot of percentages. So how would I get this 12.5 percentage? So I would just be dividing 27 by 216, and that would give me the actual relative frequency. So in terms of percentages. So I can say, for example, that if I roll 3 dice, it's more than 50%. I have more than 50% odds of getting a number between 8 and 13 in my sum. So 8 and 13, we would say, kind of concentrate most of the odds here. And so these numbers are so small here, the 4, the 3, the 17, and 18, that they take just a very, very, very thin piece of the, pizza, so to speak. So if we play the bingo with a spinner instead of a dice, this would be the way. We would just roll the spinner and then it would fall some way. And that's another way to simulate the game without using the dice. So finally, a take-home challenge for your students, and if there's time, if not, there's no pressure, to extend this problem and to start students to generalize and see more patterns. If we played bingo with 4 dice now, how would the best board look like? And that would you would start analyzing, okay, what's the lowest I can get? What's the highest I can get? And hopefully they'll, extend this idea of the distribution, this mountain here, to see intuitively that the middles are good and the extremes are bad, because it's very, very hard to get to the extremes. Whereas in the middle, you have a lot of ways to get there. For example, you see that there's a lot of 10s here, more here, even more here. Okay, that's kind of the top. And then here still a lot. Okay, 4, and here still decent, 3. So that's the reason why the middles are good. So hope you have fun playing the bingo.